Okay, this tutorial is all about square root, square, square root, square, square root, square, and completing a square, all that stuff. Let's have a look. The equation is square root of x plus 2 square root of x is equal to 1. And this is called a nested square root because we have a square root inside of a bigger square root. Well, to solve this, we have to get rid of the square root on the outside first. To do so, just square both sides so that this and that cancel. So we have the inside x plus 2 square root of x equals 1 square, which is 1. Now we still have this square root, right? Let's subtract x to both sides. So we have 2 square root of x equals 1 minus x. And then square both sides again. This, notice, it's 2 times square root of x and then square. So we can just do 2 squared, which is 4. And square root of x squared is just x. So this way, we got rid of all the square roots. And on the right hand side, just expand it. So we have 1 minus x squared. So we have to do 1 squared, which is 1, minus 2 times this and that. That's 2x. And then we add x squared. So now we have a quadratic equation. Let's subtract 4x to both sides so that we can make one side equal to 0. So that will be 0 equals 1. Negative 2x minus 4x, that's minus 6x. And that's a quadratic equation, but it's not factorable. But it's okay. I'm actually going to rearrange it. This is x squared minus 6x. And I'm actually going to leave a space. And I'll put a 1, just subtract 1 to both sides, so that's minus 1. And I'm going to complete the square because whenever the coefficient of x squared is 1 and the coefficient of x is an even number, if it's not factorable, then you should always try to use completing the square because it's easier than the quadratic formula in this situation. To do so, it's a 1 already. Take this number, 1/2 times that number, and then square. Right, that's a little formula. It's always half of this coefficient, half of the coefficient, and then square that. So work that out, that's negative 3 squared, that's positive 9. And this is a number that we will have to add to both sides. And for more tutorials on completing the square and the geometry behind it, you can check out the video in the description. Now, the left-hand side is a perfect square. If you factor it, you get x minus 3 times x minus 3, which is x minus 3 squared. Yeah, a perfect square. And the right-hand side is just equal to 8. Well, to solve this, to get rid of the square here, we take the square root now to both sides. So this and that cancel. And when we do this, make sure we put a plus or minus on the right-hand side. And we see that's x minus 3 equals plus or minus square root of 8. We can break it down. This is square root of 4 times square root of 2. And this is just a regular 2. And square root of 2 stays inside square root of 2 like this. Yeah? Then add 3 to both sides. X equals 3 plus or minus 2 square root of 2. Done. Right? No, not yet. Don't worry. I will explain why. Because whenever we square both sides of an equation, we have to be careful not to have extraneous solutions. Meaning that even though we run through the procedure, but sometimes we may end up with fake solutions, the solutions that don't actually work. And it happens whenever you square both sides. So we have to make sure that we double check. And here's a bad habit that people tend to do. People tend to just get rid of the negative because they don't like the negative. But I will tell you, in this case here, we actually get rid of the plus. So I will tell you x equals 3 minus 2 square root of 2. It's the only solution that makes this equation work. Why though? Well, I'm going to show you guys by plugging them in to the original expression. Here we go. First, I'm going to be plugging this number into the x here and an x here, and hopefully we end up with 1. So we will have the square root right here, and x is this, so it's 3 minus 2 square root of 2 plus 2 square roots of 3 minus 2 square root of 2. Okay, it's, wow. Let's see how to do it. We have to simplify this one right here first, right? So for this, there's actually a fast way to do it. Have a look. I'm actually going to write down the formula right here for you guys. Note, if we have square root, and if we can find two numbers, let's say a plus b like this, minus 2 times the square root of a times b, we will end up square root of a minus square root of b, provided a is bigger than b. And in fact, I have done the formula proof for this right here. Link will be in the description, right? You can just square both sides and see that that's pretty much the proof. But the quick way to do it is, think about two numbers, they add up to 3, and they multiply to be 2. Well, 1 times 2 is 2, and then 1 plus 2 is 3. So it's just 1 and 2, right? And remember, we want to put the square root of a first, and a has to be bigger than b. So this right here turns out to be square root of 2 minus square root of 1. Yeah, so it's just like that. Okay, so this equals square root like this, and then 3 minus 2 square root of 2 plus 2 times this quantity. Okay, all right, inside out, so this is square root, distribute, we get 3 minus 2 square root of 2, and then this times this is plus 2 square root of 2, and this times this is of course just 1, so that's minus 2. And as you can see, this and that cancel. 3 minus 2 is 1. Square root of 1 is of course equal to 1, so this right here totally checks. Now, if we have 3 plus 2 square root of 2, put this into x here and here. Notice this is a plus. In that case, we just look at the plus version. If this is a plus, that will just be a plus. If it's a plus, then the order doesn't matter, right? So for this part, well, of course, it's the same thing. You can just say that's square root of 2 plus square root of 1. Okay, so that's square root 3 plus 2 square root of 2 plus 2. And this thing is all that, so put parentheses like what we did earlier. And we see that's square root 3 plus 2 square root of 2. Distribute, that's plus 2 square root of 2, and then plus 2 and 1 is 2. Square root of 1 is just 1. So notice this is 5, and this and that together plus 4 square root of 2. For sure it's bigger than 1, because this right here is bigger than 1, and then inside it's all plus, and so this right here, it's for sure not equal to 1, because the whole thing here is bigger than 1. In fact, you could have done that all the way in the beginning. Notice everything inside is bigger than 1. Square root is an increasing function, so the whole thing inside is bigger than 1. So of course it's not equal to 1. So that's why this is not a correct solution for this. Only this right here works, right? That's it.